Good morning, everyone. This summer, I had the privilege of conducting my research at the School of Environmental and Forest Sciences, the University of Washington. And our main research question was, are hotspots of biotic disturbances increasing in western forests in the past 2 decades? So forests are very important in that they provide essential functions, such as carbon sequestration, water regulation. They're a source for natural resources, and they also provide a home for wildlife habitat. But also ecologically, they help regulate global climate and temperature. So if you've traveled anywhere around the western U.S. recently, you might have noticed these big patches of dead trees. And this is very concerning to scientists and land managers because of all the services that these forests do provide. Now, this is due to widespread, or in most of these areas, this is due to widespread insect outbreaks and affects twice as much area as wildfires. Now, this image is showing a Douglas fir beetle outbreak near Yellowstone National Park about 10 years ago. So this is alarming, but it's important to understand that natural disturbances are a natural part of forest health. So some disturbances include fires, bark beetles, pathogens, and defoliators. Fires are abiotic disturbances that are driven by the physical characteristics of forests. And for this study, we're focusing on the insects and the pathogens, as those are biotic disturbances, or disturbances driven by some biological organism. So bark beetles are very host-specific pests that have co-evolved with trees for millennia. So an example of that is that spruce beetle only attacks the species spruce trees. And what bark beetles do is that they bore holes into the barks of trees, and they live, reproduce, and carve out galleries in these trees, feeding on the live connective tissue of these trees. So this connective tissue, or the phloem, is what allows bark beetles, they feed on the phloem of the trees, and they carve out galleries, essentially girdling the trees and not allowing the trees to transport these nutrients to the rest, essentially killing them. Pathogens infect the roots of the trees and also don't allow the tree to transport these nutrients, essentially killing them as well. And then we have defoliators, which are insects that feed on the leaves and the needles of trees. They don't typically kill trees unless the outbreak is strong enough. So these trees have been adapted to deal with biotic disturbances, and one mechanism that they use are compensatory mechanisms, where one tree's bark beetle outbreak is another tree's golden opportunity. So where one tree's death is allowing another tree to have more resources. And you can think of this as a whack-a-mole game. So where one tree is whacked down by a bark beetle outbreak, other trees shoot up. So here we have, in Rocky Mountain National Park, an instance of mountain pine beetle outbreak that are specifically attacking mountain pine trees, lodgepole pine trees. And so here you can see the dead lodgepole pine trees, and in the background you can see subalpine fir trees and Engelmann spruce trees shooting up or experiencing rapid growth from the release of these resources. Now, while forests are very resilient, their resilience is being hindered, and this is due to climate. So climate is a key driver of biotic disturbances. So in a study done by Williams et al., you can see at the top where a warming climate and tree mortality are closely related. So the red line being climate warming, and the different tree species also increasing in percentage dead as warming increases. And then on the bottom you can see where a warming climate is also very closely correlated to beetle populations, where as climate warming increases, bark beetle populations also increases. And you can think of this as typically cool and cold winters are a check, or they keep populations of bark beetles at bay, and they don't allow for a longer reproducing season, whereas warming is allowing for these longer reproducing seasons and increasing drought stress in these trees, increasing the overall susceptibility of these outbreaks. So here we have a forest that is exhibiting multiple biotic disturbances at once. So again, if you're thinking of a whack-a-mole analogy, you can think of this as 3 mallets going and hitting 3 different moles at the same time, knocking them all down. So this is spruce beetle attacking spruce trees. This is mountain pine beetles attacking pine trees, and western balsam bark beetle attacking subalpine fir trees. Now this is seen to be occurring a lot more in recent decades, but less is known about the spatial patterns and the temporal trends of these multiple interacting biotic disturbances. So the goal of our study is to fill in this knowledge gap and to analyze the spatial and temporal patterns of biotic disturbances across the western U.S. And the occurrence of 2 or more spatially intersecting biotic disturbances, hereafter referred to as hotspots. So one of our questions was, are hotspots of biotic disturbances actually increasing in recent decades? And if they are, where are they happening and why? So we used aerial detection survey data and insect and disease survey data from the United States Forest Service from years 1997 to 2016, encompassing regions 1, 2, 3, 4, 5, and 6. This is all western U.S. forested areas west of North Dakota and Texas. And then we focus on 27 distinct biotic disturbances common to these areas, such as 20 bark beetles, 4 defoliator species, and 3 mortality complexes of 3 tree species. We then do a GIS analysis where data was processed using ArcGIS and Python programming language in order to define hotspots in 2 ways. Annually, so spatially intersecting biotic disturbances that occur in the same year. You can think of this as spruce beetle and mountain pine beetle attacking the same spot and year. And then cumulatively, so hotspots in space over a 20-year span. And this is okay, this 20-year span is okay, because like I said, with a compensatory or whack-a-mole mechanisms, you wouldn't expect a biotic attack to attack a stand of trees in recent years. And you can think of this as spruce beetle attacking in 2000 and mountain pine beetle attacking in 2003 in the same location. So before I show you the results, we're going to be looking at total forested area affected by at least 1 biotic disturbance. So here we're looking at if biotic disturbances are actually increasing in the past 2 decades, so at least 1. And on the left, the y-axis, it's area affected in square kilometers. Here we can see that there is an overall increase in the amount of area affected by biotic disturbances in general. Next, we're going to be looking at hotspots, so total forested area affected by 2 or more biotic disturbances in the same year. So these are our hotspots. And on the left, we have, on the y-axis, we have percent of area affected. And you can see that there's an exponential growth of hotspots occurring in affected forests, with almost 25% of that being in 2016. So we know that hotspots are increasing over time, but we want to know where they're occurring. So here we have our cumulative hotspot map, where green areas are unaffected forests, where they haven't exhibited any biotic disturbances in the past 20 years. Yellow is where there is 1 biotic disturbances, so the mountain pine beetle attacking pine trees, and you see the background compensation of the Engelmann spruce and subalpine fir trees. And then we have red, which is our hotspots, so these are areas that are experiencing 2 or more overlapping biotic disturbances. So cold spots, or areas with little to no biotic disturbance activity, occur in generally 2 locations. We can see it along the Pacific coast, where host tree density is high, but available moisture is also high, allowing these trees to be sufficiently healthy enough to fight off these bark beetles or any other outbreak. And then we also see them in drier and low elevation locations inland, where there's enough drought stress, but not enough moisture to maintain a high host density. So these forests are too sparsely populated and generally don't fuel an outbreak. And then we have our hotspots. So these are occurring where host tree density is high, allowing it to fuel outbreaks. In the middle to high elevation along mountains, and moisture is moderate. And these areas are more sensitive to drought and a warming climate, and they may experience greater drought stress as temperatures continue to increase. And this can be seen in the Cascade Mountain Ranges, Sierra Nevada Mountain Ranges, and the Rocky Mountains. So this little circle right here is Bridger Teton National Park, and I actually had the privilege to conduct research for about a month looking at forest disturbances in Yellowstone National Park. And so driving back down to Colorado to present to all of you, I was able to drive through this hotspot, and it was really amazing to see the intensity of these hotspots and how much of these trees are actually being attacked. And so this was me on July 27th, in the midst of a hotspot where you have 4 different species of trees being attacked. You have white bark pine trees, subalpine fir trees, lodgepole pine trees, and Engelmann spruce trees, all being attacked by different biotic disturbances. So our conclusions are that 30% of all affected area in the western U.S. is experiencing cumulative hotspots. And in the past 2 decades, there's been an exponential increase in these annual hotspots. So an increase in hotspots may be an indication of lowered ability for ecological compensation in affected forests, and therefore hinder overall forest resilience to biotic disturbances. So identifying these hotspots is very important because they'll aid in further investigations of the mechanisms that drive overlapping biotic disturbances and how, in a warming and drying climate, they will be affected. So future work will be valuable in quantifying the actual intensity of these hotspots through remote sensing and ground validation, like the one I had. So I'd like to thank NSF, RESESS, UNAFCO, my great mentor, and the University of Washington. So I will take any questions. So there's definitely different reasons. Sorry. So the question was, what are we going to do about this? Is there any way to mitigate, these widespread outbreaks? There's definitely different concepts to that. So there's ideas where you want to manage the land. So there's different reasons and different kind of political reasons why you would want to either, manage the land and keep these outbreaks at bay, or let nature take its course and allow these outbreaks to happen because they are natural processes. So, loaded question. Not sure. Not sure. Depends on who you're talking to. Mm-hmm. Yeah, that's a great question. And I would say, what's going on in the southern hemisphere and if there are hotspots there? Right. So the biggest concern with biotic disturbances in the southern hemisphere is that it's not a huge issue. Right. So deforestation is probably the biggest issue in southern hemispheres. So biotic disturbances typically affect temperate forests or boreal forests. So these are forests like the ones we find in North America, not necessarily the southern hemisphere. Hi. Yeah, that's a great question. The question was, why did we only look at the past 2 decades, and can we look further in the past? So the data that we acquired was aerial detection survey data, and this is data from the United States Forest Service where they have annual surveys of trained observers fly over forested areas and observe what's going down. And so The best and easiest way to assess this data is to do it in the past, 10 to 20 decades, because the protocol has been a lot more consistent. So, thank you.